Why our websites are slow. Importance of bundle size. Welcome back to FastTalks channel. In this video we will read another article. Not React.js, not a framework or the service or API, not the internet is the reason behind it. Under the hood. The story begins way back exactly 1 year ago when I was covering stories on React and React Native apps optimization. I have covered more than 15 ways in a single story on how to improve React app performance. This is the beauty of software development. It's never stagnant or monotonous, because today, even after 1 year, I read a new story that tells the impact of bundle size on application performance and a mind-boggling story to understand why websites can be slow right under the nose. For 1 year, I have covered so many stories on React application optimization, but today I have got a new perspective on seeing React applications. Bird-eye perspective finds the root cause of problems. See, it's not rocket science, but let me explain with a story. We first create an application in React.js, then we use framework and packages and add code. If our senior developer requests us to improve our React app performance, we always proceed in the so-called universal direction as explained. Check the image size, check the internet, check the API, check the code structure, architecture, or size of the repository, check the JavaScript frameworks and language twists and turns such as rendering in React.js, and blah blah blah. But what if I told you to follow bottom to top approach instead? Let's start with the question: how browser loads the website. The server sends the app a bundle or response such as HTML to the browser. Website loads HTML file, and if JavaScript is presented, it will be fetched, parsed, compiled, and executed, followed by loading of CSS. Lastly, images are loaded or being lazy loaded. Cool, so what really can be the reasons for the entire website being slow? Of course, the things which will take time, isn't it? So a lot of HTML, CSS, JS, and image. If we exclude the API response here, the only thing that will occupy most of the time to be executed on the browsers is JavaScript. Understand that images and large size files are not the culprits every time. For example, the graph below tells that if the same size image and same size JavaScript when loads in the browser, the JavaScript file takes more time to process than the image. 62 seconds for image and 2 seconds for JavaScript. Network transmission, it's not equal. JavaScript bytes is more than 2 times slowly. Bottom to top approach. Check the JavaScript file size and try to decrease it even if the JS file includes an image. Try to optimize the image. Understand the core reason how parsing, compiling, and execution of the bundle can be improved significantly. That will cover up almost most of the reasons why applications are slow. If not, then it's time to move up in the root cause list. Checking the image optimization, rendering, sharding, and API response since in order impact of bundle size. Most websites are now server-side and include more of the JavaScript code rather than HTML and CSS. Bundle when sent to the browser whether it's compressed or decompressed will parse, compile, and then execute. Imagine if I send the browser 100 kilobytes of app bundle versus I send 25 kilobytes of app bundle. What do you think, which one will take time? Webpack bundle analyzer link. Out of curiosity, the above npm package will help you to analyze bundle size by showing the image locally as shown below. The smaller the bundle size, the less load will be on the browser's CPU and memory, and the faster it will run the website. Simple, not rocket science. We have already suspected that JavaScript can be the culprit of the slowness of the app. Adding to it, if the app bundle includes most of the JavaScript code, then more time it will take to run completely on the browser. So we should consider the fact that our bundle size should be low at the end, as it will load the entire JavaScript file on the browser. Alternative to JavaScript. And I understand this, I got one more question. Then why we are supporting server-side or JavaScript-based applications in front-end? Why can't we move back to writing HTML and CSS in the front? The answer I got is no. It's not correct and useful every time in every case to use mostly HTML and CSS in front end. Frameworks like React help develop products like Figma, Gmail, e-commerce and games much easier because of directly dealing with JavaScript in the front end. Real world example. We got a new concept called the Island model. Astra is a new multi-page application framework that deals with serving HTML files only to the browser. But Astra can be used in every product. It really depends on the product type, and if you want to know the reason below is a story for it. Astra can be used for applications where heavy states are to be managed, animations, e-commerce, and dynamic websites. Is Astra fastest framework in 2022? In the end, we can develop high and a bit more complex products every time easily using HTML and CSS only. We need to have JavaScript to make development much easier. Not a switch, I recommend improving bundle size. Let's move back to bundle size impact. So how to improve it? Look for code splitting on load the required one and try to reuse and minify the bundle sizes and orders with plugins. Remove the unused dependencies, later load the dependencies, load only when asked, and cache in the output. Still improving bundle size will not be an easy task. You can check the Next.js bundle size using the below command. Run build. It will give bundle size output, and you can try making the changes and measure the bundle size improvements. The most efficient way is to check the entire app bundle in the browser inspect tab. In the performance section, you can Google the way. It's not too hard to understand, so not covering it much in this story. Try introducing changes such as code splitting, caching using wrap query or service worker, unify the final output size using orders. You can keep measuring the bundle size locally, followed by checking the final performance in the inspect tab. The performance measured by the Google Lighthouse will also give a percentage output of the performance. Root cause. The root cause of the JavaScript and who carries the JavaScript is the app bundle. Why app bundle really matters is because the more its size, more CPU power and memory it will consume, more time it will take to get executed. Understand this also sometimes apps are fast even though the bundle size is okay. In that case, either the CPU of the browser is really slow, it usually happens in the old devices, or the network connectivity is low. Nothing more than that, nothing less than that. Ultimate plan of action. Which phone app is tested? If the phone is slow, then check the app on the new phone. Make sure internet connectivity is good. Even if the app is slow in all the phones with good internet connectivity, then proceed with bundle size. If bundle size is not an issue, check the image size and other terms such as rendering, HTML parsing, fonts, and CSS, and so on. The bottom to top approach will have a new way of addressing the entire application performance issues. Final verdict. I am hoping to see more tools in the future helping in following this approach because nobody is talking about it. I am able to find the root cause because I read the story written by the engineering manager at Google, Eddie Osmani. Conclusion, I am reading more about bundle size for app performance and the root cause behind our apps being really slow. Because I'm done adding image optimization, React rendering issues, and the usual way of optimizing applications, it's time to go beyond finding the root cause and play with it. Until next time, have a good day. Shrey, I had reading. Thanks for watching. Bye.